Hi, in this video, I'm going to explain question number 1 of homework 11, the last homework of probability and stochastic processes course. So let's dive into the question, and I want to check that everything is okay. Yes. Uh, in the first question, we have a stochastic process x of t, which is a real WSS, and we know that WSS in for the stochastic processes means that the expected value for the stochastic process, the e of x of t, is a constant, and the auto correlation, which is the r of xx tau, is a function of tau, which is t1 minus t2, and so it means that the autocorrelation it depends only on the difference of t1 and t2, which is tau. And in this question, we have the power spectral density S of xx of omega. And we know that the spectral density, in order to find the spectral density, we should calculate the Fourier transform of the autocorrelation. And I will talk about these details in my answer. Okay, given all this information, we want to answer the first part. And we want to prove that the autocorrelation of x is real and even. So let me check. Okay, so to prove that the autocorrelation is even, we start by writing the r of x tau is equal to r of xx with some shift. So we want to calculate the autocorrelation between t plus tau and t. So from slides, we know that the formula for autocorrelation of t1 and t2 is the expected value of x of t1 times x of t2. And here t1 is t plus tau and t2 is t. And we can change the order, so we can write it so the expected value of x of t plus tau times x of t is equal to the expected value of x of t times x of t plus tau, because we know that this stochastic process is real. So here the r, this is equal to the r of x t and t plus tau. And we can write this as the r of xx minus tau times the r of xx tau. So in this part, we could prove that for stochastic process x, which is WSS, the autocorrelation is even. Now let's go to part B. In part B, we want to prove that S of xx omega is even and non-negative. So first, as I said, the spectral density is equal to the Fourier transform of r of xx. So we've written the formula, and after that we can substitute E with sum of cosine and sine. So we have this, and as r of xx tau is even and sine is odd, this part that contains sine is odd, so the integral is equal to 0. And we are going to focus on the first term, and the first term has cosine, and we know that cosine is, we know that the cosine of w tau is equal to the cosine of minus w tau, because it is even, and we know that r of xx is even, so the r of xx tau is equal to r of xx minus tau. Actually, we had this from the before, that r of xx tau is equal to r of xx minus tau times r of xx tau, that we have put here, and we have did a multiplication to number 2 here, and as you can see, we got to the s of xx of minus omega or minus w. So we've proven that s of xx is even, and because the range of integral is from 0 to plus infinity, it is also non-definite. So the proof is complete. Thank you.